Wired and wireless networks are interesting to compare and contrast because, although they ultimately serve the same purpose of providing internet connectivity to some amount of people, the way that they complete this purpose, the risks associated with each, and the strategies that are used with each can either be wildly different or shockingly similar. Wireless and wired networks work very differently in the physical and data link layers of the OSI model, since they work over the air instead of through a physical wire, and these two layers are where wireless LANs operate. For instance, on the physical layer, wired networks can detect and mitigate data collisions, whereas wireless networks must use some very complicated protocols that can control and avoid data collisions. Additionally, wireless networks have unintentional interferences that wired networks do not have to deal with due to the nature of wireless communication interacting with other kinds of wireless signals, which are also handled on the physical layer. These two layers are also responsible for forcing the data to conform to 802.11 standards. There are numerous security risks associated with a wireless network, and many of those also overlap with risks for wired networks, or at least have some equivalent. Passive monitoring, for instance. Over an unencrypted wireless network, a network might accidentally extend out beyond where a company's building into a parking lot, or the like. From there, a computer can be set up to monitor the traffic that goes through that network. Over a wired network, a computer can be set up right next to the physical wiring, and with extremely sensitive equipment could listen in on the traffic over the network. Unauthorized access is another risk, and it can be gained through several different ways on both network types. Wired networks can be accessed through physical means, like logging into a company's physical machine illegally, while wireless networks can be accessed through ARP poisoning to make the attacker's computer seem legitimate on the network, or unrestricted access to a network through a rogue access point. DOS attacks are achieved through overwhelming a network through one of several means, and while wireless networks are probably the most vulnerable to them, both are susceptible. Ultimately, neither network type is immune to attack, and there are many risks associated with both, which often even are the same or similar across the two networks. A lot of mitigation strategies for wireless networks revolve around implementing security on the wireless communication. To mitigate the risk of passive monitoring, the network traffic must be encrypted so that the attacker cannot understand the transmitted data. To mitigate issues of unauthorized access, device and user authentication can be implemented to ensure that no rogue access points are added to the network. Or if the attacker is using ARP poisoning to gain unauthorized access, then enabling ARP handler inspection or ARP security can ensure that there are certificates to check authentication against. DOS attacks are very difficult to protect against, but keeping equipment up to date can help, and making sure that there are redundant systems to ensure that the company's network isn't fully offline for very long, even if the DOS attack takes down the primary network, is the best way to prepare for an attack. Wireless network communication presents some unique attributes and challenges that have been, and are continuing to be addressed throughout its lifetime. One such challenge is the issue of exchanging private keys over the air to unlock encryption. This is not an issue that wired networks have to face, because the connection between devices is automatically more secure. As just mentioned, the inherently less secure nature of wireless communication continuously plagues wireless networks, and require many authentication tools, encryptions, and other strategies to keep data safe and secure. Signal interference is another unique problem that wired communications were able to solve fairly easily by shielding their wires. For wireless connections, it is obviously not an option, and instead there have to be strategies employed to ensure that the signal is only as strong as it needs to be, and is kept away from other strong signals like radio, as well as many other workarounds to ensure that the connection isn't overrun by a different signal. The differences, boons, and issues between wired and wireless networks are often parallel to each other, but ultimately create mediums that need to be handled very differently in order to be effective.